In this video I'm going to be looking at the solution to question 6 of the January 2010 paper for Edexcel FP1. The topic of the question is complex numbers. In the question we're given two roots of a cubic equation where two of the coefficients c and d are unknown. We're first of all asked to write down the other root, and then with the information we've got to find the values of c and d, the two unknown coefficients. Having found those values, we're asked to show the three roots on a single Argand diagram. Well, you can see that one of the roots that we're given is a complex number, and because in this type of cubic equation the roots must occur as either real numbers or a complex conjugate pair, then the other root is 5 minus 2i, the conjugate of 5 plus 2i. Once we've got that, we can then write down the cubic as a product of its factors. So writing each one in turn, we've got x minus the one root that we've been given, 5 plus 2i, x minus the other root that we've just found, the other complex root, 5 minus 2i, and finally the third root, x minus 2. And multiplying out these two complex ones first of all gives us x squared for the first term, so the x multiplied by the x, and then we get two parts, one which is minus 5 plus 2i times x, and the other one minus 5 minus 2i times x. So the imaginary part of that will cancel out, leaving you with just minus 10x. And finally the two complex numbers multiplied together give you 5 squared and then minus 2i all squared. So that then gives you a total of 5 squared plus 2 squared, or 29. Well, we now need to multiply that by the other factor. Well, we don't actually need to do the multiplication because what we need to do really is to compare this with the cubic that we've got, x cubed minus 12x squared plus cx plus d. And we don't need to do the multiplication because we can see that the d term comes from the two numbers here multiplied together. So d is clearly 29 multiplied by negative 2. So d we can write down as then being equal to negative 58. The c value is the coefficient of x. Now that comes from two places on the left hand side, 29 multiplied by x and then the negative 10 multiplied by the negative 2. So in total then we have on the left hand side 20 plus 29, which is a total of 49. The mark allocation for these two parts of the question, well, there's a single B mark, in other words no method needed there for the second root, or the third root rather. There's then a method mark for multiplying out the factors to get to this quadratic A1, and then a method mark for comparing the left hand side and the right hand side of this equation. Finally, two A marks for the values of c and d. A total in that part of the question of 5 marks. In the final part of the question we're asked to show all three roots onto a single Argand diagram. Now this doesn't need to be done very accurately, although your sketch should be neat and should be well labelled. So what we're looking for then are the roots marked at 2 on the real axis. So I'll just mark that in as being the real axis. And then the others are a conjugate pair, so they must be symmetrically placed, one at 5 plus 2i and the other one at 5 minus 2i. So these will be symmetric about the real axis, reflection. And just labeling up the other axis as the imaginary axis. There were 2 marks available for that part of the question, and that was for fully correct and labeled diagram. Right, that's the end of that question. If you want to see any other questions, then you can find information at www.furthermathematics.org.uk.